Welcome to my YouTube channel Mechanical Magic Mechanical Learning Tutorials. So in this video I would like to solve some of the problems of polytropic process, and that will be PV raised to 1.3 equal to constants. So here it will be the data for the problems. Let us see. 0.67 kg of gas, so that will be the mass is given. So here m is equal to 0.67 kg at 14 bar, and that will be the initial pressure. So P1 14 bar, so that should be converting into pascals. So P1 equal to 14 into 10 raised to 5 pascals, and 290 degree, so that will be the initial condition of the pressure and temperature. So here it will be the temperature T1 290 degree centigrade, so that should be converting into Kelvin. So T1 equal to 563 degree Kelvin. Now is expanded to 4 times of the original volume. So here it will be the V2 is given in the form of V1. So just you can see V2 that will be equal to 4 times of V1. So V2 equal to 4V1. And according to the law, PV raised to 1.3 equal to constant. So that should be your polytropic process. So to calculate the original and the final volume of the gas, so V1, V2, the final temperature of gas, so that will be T2, the final pressure of the gas, so that should be P2, work done of the cycle or you can say system, and that will be the W, and take the value of R 287 joule per kg Kelvin. So from the data, let us see on to the PV diagram of the problems. So here with the x-axis that will be volume, y-axis it will be the pressure. So from the initial conditions, 0.67 kg of gas at 14 bar and 290 degree centigrade is expanded. So point number 1 is here, and it should be expanded to the point 2. So it will be look like this. That will be the expansion process by polytropic. So according to the given data, P1 and that will be 14 bar, T1 290 degree centigrade. We have to calculate the V1, we have to calculate the V2, we have to calculate the T2 and P2 also. So here it will be the area under 1 to 2 process, that will be called as a work done by the systems. So let us see, or you can say start with the solution. So we have the relations of P1 V1 equal to MR into T1. So equated with the V1, and that will be equal to MR T1 divided by P1. So just put the value of M, so that will be from the data 0.67, R that will be given 287 joule per kg Kelvin. So generally that will be, you have to take the value in the case of joule per kg Kelvin, and T1 563 Kelvin divided by P1, so 14 into 10 raised to 5 pascals. So if you calculate, then you will get the answer. Initial volume that will be 0.0773 meter cube. So that will be the original volume. And from the relations, like the original volume, it will be V1, and the relation from the final volume and equal to 4 into V1. So just put the value of V1 over here. So that will be V2 equal to 0.3093 meter cube. So that will be the final volume of the system. Now according to the polytropic process, PV raised to 1.3 equal to constants. So P1 V1 raised to 1.3 equal to P2 V2 raised to 1.3, and equated with the P2. So P1 into V1 upon V2 whole raised to 1.3. So just put the value of P1 and that will be 14 into 10 raised to 5. V1 from here, initial volume. V2, that will be the final volume, and raised to 1.3. So by the calculations, you will find P2 equal to 2.3 bar. So that will be the final pressure of the gas. Now from the polytropic relations from the temperatures and pressure, so T2 divided by T1 equal to P2 divided by P1 raised to n minus 1 upon n. So just put the value of T1 and that will be 563. P2 from final pressure, P1 that will be initial pressure, and you will calculate the temperature 371.40 Kelvin. So that will be the final temperature of the system. Now last one, that will be the work done by the polytropic process, and that will be P1 V1 minus P2 V2 divided by n minus 1. Just put the value of P1, V1, P2 and V2 and you will get the answer 128.9 kilojoule. So this is a simple method to calculating original volume, final temperature of the gas, final pressure of the gas and work done by the polytropic process. So thank you very much. If you like it, then subscribe and share. Mechanical Magic, Mechanical Learning Tutorials.